1 minute. Yes, recording has begun. So let me share my screen. So people in the class, please confirm whether the screen is visible.
Yeah, it's visible.
Okay. So last class, if you had seen, the last class happened on 17th February. No, after that I'm able to take class today because of tight schedules. So on this day, I get completely given theory for series of positive terms. Okay. So there's only one theory part is remaining. That is alternating series. I'll finish that concept today. Alternating series. Okay. Look at this very carefully. What is the meaning of word alternating? Alternating means you're having a series wherein you have plus minus terms in a series. That is called alternating series. Okay. Do this carefully. Suppose you take an example. Suppose I'm telling 1 by 1 into 3 minus 1 by 2 into 4 plus 1 by 3 into 5 minus 1 by 4 something like this. Okay. This is an example of alternating series. Why? Because this is positive. I'll use this color. This is positive. This is negative. Pause like that. You understand? This is the meaning of alternating series. Now, there's a very important concept which I'll try to make it very clear. General term. Listen carefully. Writing general term alternating series is very important. Okay, listen very carefully. Let the general term be represented by un. Okay, when you're writing un, you consider only the positive portion. I repeat, when you're writing un, consider only the positive portion. Don't write -1 power n minus 1. Now, can someone try? What is un for this term, for the sequence? One volunteers to tell the answer. What is un for this? Yes.
By n into n plus 2.
Yes. U1 you are writing as 1 by n into n plus 2. Okay. Don't write -1 power n minus 1. Okay. Don't write that. And what after I'm writing the part, this is only positive part. Now after I'm writing the positive part, I will say like this. Let the series be represented by sigma of -1 power n minus 1 u1. Clear? When you are writing sigma part, here you insert this term. Don't write this inside this itself. Okay. This you keep positive. By writing the series, you write sigma of -1 power n minus 1 u1. This is the series. Series is generated. Are you having any kind of confusion on this? It was very important. If you are listening carefully, you can also do like this. That is, you are writing u1 as -1 power n minus 1 by n minus n plus 2, and you can say series is sigma u1. Okay, this is also correct, but this will lead to a lot of confusion. Leads to confusion. Avoid it. Okay. I hope I'm clear. Both are correct, but please, I am recommending. I'll do all problems with considering like this. Okay. When you are taking u1, please take it as only positive. Don't do this. Okay. This is correct, but will cause confusion. Okay. Am I clear? Can I proceed?
Yeah, Praju.
Yes.
Okay. I'll do this carefully. So now we will see this concept of Leibniz test. What is this? Leibniz test. Yes, Leibniz. See this test. Listen carefully. This test, how to test for oscillation? Listen carefully. Test for oscillation. What you're doing is you are taking last term. What is this? Last term. I'll write separately. If it is not 0, then I can say sigma of -1 power n minus 1 u1 is oscillatory. Okay. So last term should not be 0. This is the concept. Okay. Last term should not be 0. If the last term is 0, not 0, sigma, this alternating series is oscillatory. Okay. Hope this is clear. And now we'll see test for divergence. Sorry, convergence. How to test for convergence? Listen carefully. First, we need to check. There are two conditions. We need to check. One by one and write, and different color and write. First condition is limit n tends to infinity, u1 should be equal to 0. Second condition is u1 should be greater than or equal to u1 plus 1 for all n belongs to natural numbers. Okay. Hope it's clear. Okay. If these two conditions satisfy, then you can say alternating series is convergent. Then is convergent. See, Leibniz is used to test convergence. Write it first. Test for -1 sigma -1 for n minus 1 u1. So for this we are performing tests. This series we can say is oscillatory if this condition is satisfied. We can say it is convergent if these two conditions are satisfied. Now, third question you will ask me, what is the test for divergence? Can someone think? What is the test for divergence? Can someone try?
If the condition fails, it is divergence. If the above two condition.
It sounds correct, but the actual answer is Leibniz test cannot test divergence.
Yeah.
You will not see a single question in this chapter. I mean, in our syllabus, wherein you are having an alternating divergent series, you will not see. Okay.
Yeah.
Because because the test is designed like that. The person who designed this, you should go ask him why. Divergence போடல. You should ask him. Okay. Divergence. See, this is not the only theorem. Alternating series is a big concept. There are many other theorems. Other theorems maybe I don't know. This I have tried to analyze. Okay. I tried to check for divergence, but then only clearly many websites that mentioned that Leibniz test you can't use for divergence. Okay. So Leibniz test used when you can only conclude whether it's oscillatory or convergent. You cannot conclude whether it's divergent. Is it clear? You will not get any question also. Okay. Can I proceed? I'll do two questions. Okay. So it definitely will be clear. Don't worry. Two questions I'll do in this chapter. Okay. Look at this. 3 I'll do. Series. Now, if it is convergence, listen carefully. Two types of convergence. There are two types of convergence. Those two we will see, and how to differentiate we have to see. Listen carefully. Let sigma 1 -1 for n minus 1 u1 be a convergent alternating series, which we should prove by Leibniz test. Spelling, please don't mind. Okay, not the spelling properly. So now what we'll do is, if sigma of u1 is convergent, then I'll conclude that sigma of -1 for n minus 1 u1 is absolutely convergent. And if sigma of u1 is divergent, what will I conclude? It is conditionally convergent. Now, please do not ask the logic behind why it is like this. Even I don't know the logic. They are just given some terminology. Just memorize it. Okay. What you need to focus is sigma -1 for n minus 1. This is alternating series, correct? But what is just this? If I'm writing only sigma of u1, what is it? This is. Can someone tell what is this?
It is a normal series. Normal.
What is normal, abnormal? Positive term series.
Positive terms.
Okay, that's it. Okay. So to test for convergence, listen carefully. We are testing convergent divergent for positive term series. Leibniz test, you cannot tell whether the alternating series is divergent. Don't get confused. Okay. We cannot test whether the alternating series is divergent. But u1 is positive term series. This you can check convergent divergent because last class fully taught that only. Last class fully taught that only. How to check whether positive term series convergent divergent or convergent divergent. This is full class I taught last. Last class fully I taught this only. So this we can check. You understand? Is there any kind of confusion in this? See, confusion will arise when you are keeping, when you see, I told you initially, you're keeping like this, then then you will have to put mod and all here. You'll put mod and all unnecessarily. But if you are assuming this itself as positive, see what I told you, assume this itself as positive. then this unnecessary putting mod problem won't be there. Okay, mod confusion we don't need. UN you keep positive. Let the series be represented like this. You write like this, 100% you'll be having no sorts of confusion. I am giving guarantee. Okay, so second we'll do 3 questions and we will see whether you're able to understand. So easy question only, not going very difficult question. So I am giving you series 1 minus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5. Please test this. If it is oscillatory, say oscillatory. If it is convergent, say convergent, and also type of convergence. Divergent you cannot tell because Leibniz test does not test for divergence. Please. I'll give exactly 1 minute. Please think and give me the answer.
UN சொல்லணுமா அப்போ?
Yeah, first you tell the final answer. Final answer முதல்ல சொல்லு.
Conditionally convergent.
Conditionally convergent.
That's it. It's very simple. See, very simple, right? So 1 minus 1 minus, so you are writing U1, you're taking as 1 by n, only positive part, and you're taking series. Let the series be, series is sigma minus 1 power n minus 1 U1. Okay. Now do like, first you are doing limit n tends to infinity U1. What is it? Limit n tends to infinity 1 by n equal to 0. So first condition satisfied. Leibniz test. Second condition, what is it? You check U1 by U1, you just do ratio. Okay. What you will get? You will get 1 by n plus 1 equal to n plus 1 by n. Okay. See, numerator is always greater than denominator. Numerator is greater, obviously, correct. It is always greater than 1 for all natural numbers. So I can conclude what? I can conclude U1 is greater than equal to U1 plus 1. Second condition also satisfied. So you should say all steps I am writing. I know you can solve the question, but steps you should write like this. Only then you will get marks. By Leibniz test. Spelling alone you should thoroughly learn. Please learn the spelling. I'm forgetting again and again. Leibniz test. Write clearly. Sigma minus 1 power n minus 1 U1 converges. Then what you will do? Now check sigma U1. What is sigma U1? Sigma 1 by n. I can write as sigma. Tell me how to check this. How to check whether convergent. What test you can use? How do you conclude about sigma U1? Come on.
P-test. P-test.
The normal convergence test and say it's divergent, right?
And use all the P-test is best. Directly we are telling you P is 1. P-test you can use. You can say P equal to 1. So P is less than equal to 1. For P less than equal to 1, it will be divergent, correct? Okay. That is sigma U1 is divergent. So sigma U1 is divergent, what I can conclude? So sigma of minus 1 power n minus 1 U1 is conditionally convergent. That's it. Okay. Any confusion?
எனக்கு ஒரு டவுட் இருக்கு லைக் இப்போ u1 is equal to un plus 1னா உனக்கு வந்து sigma of minus 1 whole power n minus 1 un வந்து கன்வர்ஜென்ட்டா இருக்காதுல்ல ஆசிலேட்டரி தானே இருக்கும்.
Condition for oscillating இங்க clear எழுதிருக்கேன். Condition oscillating கடைசிலும் 0 கூடாது. It's not 0. So like 0 when it's come, why are you talking about oscillatory itself?
ஒன்றும் இல்லை.
Now, even small question. 5 minutes more, we'll finish series. We will go to differentiation. Don't worry. So, question 2. We'll discuss about this. Tell me. What is the answer? Only 2 answers are allowed: oscillatory or convergent. And convergent, if you're saying, you should also tell me whether it is conditionally convergent or absolutely convergent. Please tell me the answer to the question.
தெரியல ப்ரோ எப்படி போடணும்னு.
Very simple, yeah. Very simple, not difficult at all. Check the first condition. What is limit n tends to infinity?
Is it oscillatory?
0 cos 0 1, so it's definitely not convergent.
Oscillatory, that's it.
Okay.
Actually, I'll tell you one truth. This is a part of the assignment let's there, okay? Really, this
Rajwal,
confused me
is
also.
it even alternating
There,
series?
That's there. I mean, not it's part of a question. What I'm saying is, such questions actually questions will be simple like this. Even I'll tell you, even I got confused in this. I put in net and saw one word, one sentence. I did this. So one thing is sometimes it will be very easy. We will unnecessarily think too much. Okay, so don't worry. Not a problem. Look at this. Last question actually is very obvious question. Just for sake of doing one question in this model, I'm doing okay. The question is 1 minus 1 by 4 plus 1 by 9 minus 1 by what is next term 16. Do this. Tell me what kind of series is this?
You are absolutely convergent.
It's simple, no wasting time. So I can say
Convergent.
first what is u1? u1 is 1 by n square.
1 by n square.
And series is, write this, okay? Always every question write this, okay? So I'm writing limit n tends to infinity. u1, what is it? It will be limit n tends to infinity 1 by n squared equal to 0. And second, what will be? 2 u1 by u1 plus 1. What is it? It will be n plus 1 whole squared by n squared. This is greater than equal to 1 for all n belongs to natural numbers. So both conditions satisfied in Leibniz test. So I can say sigma minus 1 power n minus 1 u1 is convergent. Then now you take only this positive part. Now sigma u1 will be sigma of 1 by n squared. Here p equal to 2 according to p test. So as p is greater than equal to 1, I can say sigma u1 is convergent. So as sigma u1 is convergent, sigma minus 1 per n1 will be absolutely convergent. You will not have any confusion in this model, and I'm again stressing you are not having any confusion is because you are taking u1 like this. You just try and see one time. You take u1 like this and see now. Try and see. You're taking ratio, you'll get minus all the other confusion. Like, I'm going to put mod here. No need at all. Okay. You take u1 as positive, half of your problem is over. Okay. This is all about alternating series. Same thing in every question, same, nothing for me extra, nothing is there for me to discuss extra. Okay. I have solved the assignment. I have put it, I've already uploaded. So ma'am has given, you know what she has given. She has given 1, 2, 3 questions. Here she has given 5 questions. Here she has given 5 questions. Here she has given 5 questions. Assignment, talking about assignment.
மனசாட்சியில bro ma'am kana.
நிறைய sum கொடுத்தாதான் you'll be able to practice, okay? So practice, I'll tell you, if you do a sheet, it's enough. A sheet pakka, I'll tell you, she'll copy a question from sheet also. Last time, last 2 or 3 questions directly from sheet. So please do the sheet before going. I'm giving you advice, okay? This is fully from alternating series, full alternating series on this, okay? So I uploaded, you can go see. It will be practice for you, okay? Because I cannot waste time in taking a lot of classes. Because even my schedule also is tight, your schedule also is tight, okay? So that's all. I'm ending alternating series. I'll just stop the recording and start another recording. 1 minute.